Welcome to Ask and Learn.
Hello students, in this question what is being asked is that we have a table. So this is a table and we start from a point, let's say this point, right, 0.5 meters from the edge of the table. We start from some point beyond this and start rolling a toilet paper. So it starts rolling and falls down. So it reaches a point on the ground and we need to find this point, and that will be the distance. And starting from here, initial velocity v0 we need to find out what the velocity when it reaches this point, and then how much farther does it fall off the ground. Okay, and this point is what we need to find out. So we need to find out three things. We need to find out the average speed of the toilet paper v, and we need to measure the distance d from the bottom, and we need to find out the percentage of error in the calculation that we made. So it is given as a percentage of error is equal to d minus d by d times 100. So this is how this is all that we need to find out. So as you can see, it starts from this point, right, this point. So the actual motion starts from this point and it goes to this point. So it will have some kinetic energy. So the energy conservation will be there. So it falls off to the ground with an initial velocity with the projectile at an angle based upon the initial velocity. The initial velocity projects this in this direction, right? So we can find that point by experiment. So what you need to do, you roll off 10 20 times and then you find out what the distance it is going to be there. So we can use the equation to find it theoretically. S is equal to S0 plus ut plus half at square. So at this point, the this object is being experiencing the gravitational force. So whatever the mass of the body is shown that it will be pushed down. So mg will push it down, right? That is a force in this direction, and it has a velocity component in this direction, that is v0 component in this direction only. So s in the y-axis, the distance in the y-axis, which is the height of this table, that is height of the table, must be equal to initial point. Let's assume this point to be equal to 0. This is the height of the table, um, plus initial velocity in the y-axis is 0. So 0 plus 0 plus half g times t square will be the distance. So whatever the height of the table is, if you can measure that, t will be equal to 2h by g, the square root of that. That will be the time taken for the fall. So we can find out the distance in the x-axis. That is what is it is going to be traveling. So it's starting from 0. It will travel 0 plus initial velocity v0 times t, which is root 2h by g, and there is no acceleration in that point, right? There is no acceleration in the x-axis. So this will be that. So sx, that is equal to the distance, will be equal to v0 times square root of 2h by g. So this is the distance traveled in the x. Now this is the experimental, this is the theoretical part, right? That is the distance, this distance. So the initial velocity, if you know the initial velocity at this point and at this point, without friction, it will have the constant velocity in this direction, ignoring friction. So it will be v0 here as well. So when this happens, what is being meant? So what you need to do first is you need to conduct this experiment. You need to do this 10 times, and you have to start from this point and you have to measure this point as well. So mark this point and take the average. So now you know the v0 value. So s and serial number, then v0 value, d value, which you can measure, and then you can take the average of all these things, v0 and d, and then substitute back into this equation to see if it fits, right? Do this again and again, and you can find out the value in here, so that you can match up with the h value, which is a constant, and g value, which is a constant. So it must satisfy this equation. So that is the basic foundation of this experiment. Now coming to the error part, you have to measure the errors, right? So error, percentage of error will be equal to, in your calculation will be equal to whatever the d value is, and d minus d, which is the, so this d is the measured value, right? This is the measured value here, and d value you can find out, which is the actual value, right? Actual value that you have calculated using this equation. Using this equation, this is the d value, this is actually the d value, and this is the small d value. So small d value and d value, you have d minus d by d times 100 will give you the percentage of error. So that will be the experiment. So each time you do, you will have it v0, d and d, which is varying, and you can just calculate the percentage of error. So what is the acceptable fraction of error? You can go up to 10%, that is acceptable with experimental measurements. Anything beyond 10%, you should ignore it. Otherwise, it will fluctuate your value from your original point to a different point, which is wrong. So this is the solution. I hope you find the solution useful. Thank you.